And in words?
How much the material can stop the flow?
Yeah. It's a material constant that measures the ability to stop the flow of current, yeah.
Can we, like in the exam, if it's asking for definition, like can we use the formula to define that?
As long as you...
That's
a given.
Rho equal and L
yes,
equal.
that's also the given, but that you explain what each term stands for.
Yeah, for sure.
Like A for area.
Yeah, all this stuff. Yeah. Exactly. Okay, so I don't think we need to do the first part. So the B part here, you have a length of a wire, and you can see you have the voltage, and you have the current, and you have the power supply. And as you change the length, you notice you get different currents and different resistance values. Although the only thing you can see that's changing is the current. But you can measure the voltage if you wanted to. But this table only has the current, and they have the length here. And they want to know what is the resistance for this length and this current. And you might be thinking, oh, well, how can I do that? So you need the formula that gives you OR if you know I and L.
I and L?
Yeah, no, that's the thing, we don't have one, really. But we do have this formula, if we know the L, right? And we do have this formula. Yeah, so maybe we could put these together to try and get OR from I and L.
Fine with the V goes to IR, because we have the V and
you have the V1.256.
Yeah.
And you want the
oh yeah, it says it keeps the voltage constant. So yeah, you know the V. Oh, so then the OR is...
I need the A.
V over I, yeah.
No, actually this is enough. V over I.
Like the length is I think extra. It's for the second part.
Yeah, it must be for the next part. Did you get it, Sharif, or?
I R equals V over I.
Yeah.
And I is 2.25
Yeah. So I hope that my OR gets bigger because the L gets bigger and the I gets smaller. So yeah, it looks okay. I need to open up Excel to make the graph. It's only 2 marks actually, so it should be pretty easy. So we're using the formula here. OR equals 1.25 over I. Can you just please write this table down, and we'll do this together. So if you just copy this table down, please.
After the exam, how many days will it take to give the results?
Weeks.
6 weeks?
So much to do. Sorry. Yeah. You'll understand. No, actually, you're a working man. You're busy at work, right? Yeah. Things to do.
Yeah, I'll be staying here for 2 months. And then I'll go back to Pakistan.
Yeah. Maybe I'll pop into Topaz and say hello, let you know how your exam went. Okay. Did you write this table down? Yeah, so the first one is length in meters.
I in
The next one is I in amps, and the last one is OR in ohms. And the length starts at 1 and increases by 0.25 each time until,
2.25.
and then the current starts at,
2.55.
yeah,
2.08. 1.58. 1.40. 1.12.99.
and we think the ore should be, according to our formula, 1.25 over the I.
I'm getting bigger.
Yeah, and we'll do we'll do 3. 3 significant. 3 decimals. Okay, so that answers that one for only 2 marks. The next is the graph of R on the Y and L on the X. So the R on the Y and the L on the X. Okay, now let me just because I don't need this, I'm just going to move it over to here, get it out of the way. And are you looking at me, Sharif? Yeah, this is on the X and this is on the Y. So I'll plot this. Insert chart. Now this is really nice because I think it said, what was it, 4 marks?
Yeah.
It's good. Okay. So the graph's name needs to be resistance against length.
Yeah.
And on the x-axis is L in meters, and on the y-axis is R in ohms. Let me get this graph. It's too big, of course, so let me just shrink it down a bit. Come on. What? Yeah, I know it's small, but it doesn't matter.
It's really line.
It practically is a line, yeah. Let me put the line in. There we go. Right, that's all nice. So that answers that for 4 marks. Now, for 5 marks, if you know the diameter, use the graph to calculate the resistivity. Now, this isn't a question we did in class. This is a good example of where you have to think for yourself.
We just have to find out with the, because we have the
Well, let's see what we have, okay? So our graph has R on the Y and L on the X. So we want some formula that has R, L and rho in it.
Yeah.
Well, actually, let's look at this formula. This actually is it. R is on the Y, L is on the X. So what is this then?
It's the slope.
It's the slope. So then the rho will equal the slope multiplied by A. Because this is equal to the slope.
So multiply by L.
No, this is the slope.
Yeah.
So if this is the slope, then rho is the slope multiplied by A.
But you need the slope or the...
I need both slope and A. Now I have the slope. The slope is 0.63.
How will we find it?
Yeah, how will you find it? You can use the formula y2 minus y1 over x2 minus x1. Or you can draw a triangle and do the rise divided by the run.
Which one is it?
They like the triangle in the marking scheme. To draw a triangle on the graph like this and measure this length and divide it by this length.
It's the same.
Yeah, it's the same. Should be the same, yeah. Anyways, we have the slope and we have the area is pi r squared, and we know the r. It's
V over 2.
Yeah, 1.1 millimeters over 2. So if I multiply this by this, I'm finished.
It's square also. Yeah.
Oh yeah, thank you. So let's see what we get. 1.1 divided by 2, multiply 10 to the power of minus 3, squared, times pi, times 0.63, and we should do it in something like micro, nano,
The U.
huh? 599 nano something. I have to think about what the constant is. 599 nano ohm meters. Very good, thank you. Ohm meters, nano ohm meters. That's the unit for this. That's the answer. How many marks so far now? That's 5.
It's so good.
So the graph and the slope together make 9.
10, 11.
So that was, remember, I had one of my rules. Always do the graph question, always do the atoms question, and probably should do the materials question.
Alright.
Especially if it has an ideal gas law in it, because you do that in chemistry. Yeah. So always do the graph, always do the atoms, always do the ideal gas law.
Again, type of question if there is an exam like it's good. You can put one.
Describe an experiment to get the IV characteristic. Now you actually did this experiment. This is the one where yeah, you have the resistor, you have a variable resistor, you have the power supply, you have a switch, you have an ammeter, and then you have the voltmeter, and then you adjust this here, and then you measure or you read these, and then you make a graph where this is I and this is V, and
The slope is R.
And the slope is R, 1 over R.
Oh.
Now, remember I said a while ago we don't really learn all the experiments for the exam because there's about 12 of them, or even more. It would take about 8 hours to do it, and it only is on half the exams, and when it is on half the exams, it's only like 2 or 4 marks. So like here's my example, this is only 4 marks, and it's only on it half the time. And anyways, this was an experiment that you did for your lab report.
Yeah, so and
Oh, so just to finish, for this one here, what is the graph for an LED? Now an LED, do you know an LED?
Yeah.
The little LED lights? I'll give you an example. This light here, if the voltage gets very high and the current gets very high, it gets very hot. If it gets very hot, it makes more resistance. So the resistance gets bigger, which means the slope gets smaller. So the graph of something like that would probably go like this. Now I think for an LED, I don't think they get too hot. So I feel like an LED will be straight like this. But some LEDs, they're made so that as they get warmer, they become a better conductor. So their resistance actually goes down as it warms up, which means the slope, what happens to the slope? No, if the resistance goes down, it gets bigger. So the graph, I feel, might then start to curve up.
yeah, because the LEDs in the car, they are in the same way.
Probably, yeah.
Like there are particular LEDs which are, the more.
No, I know, yeah. I think they're made of.
Acceleration, the light is.
You know what? We can just check the answer here for this one. But I have a feeling the graph curves up. But before we check the answer, let's look at the last one. Oh wait, I accidentally did. I did both at the same time by accident. The first part was just the experiment,
So the diagram.
and the second part is the diagram.
No.
Is it?
Draw a diagram here to show the
So
idea.
describe an experiment is the first diagram that you made. We have
Yeah.
to explain the diagram.
Yeah. And then the next thing is to draw the graph. However, they tried to catch me out here because they want the graph in the positive and the negative as well. So they want you to draw what happens if it gets negative voltage. Now nothing really happens. Do you remember when we did the experiment? If you have the circuit the wrong way, the voltmeter, you get the same number on the voltmeter except minus. So if everything is backwards, then you get the same numbers, but they're both minus. So in that case, the graph just looks like the image, the mirror image of this one here. There's no difference to it. It's the same except upside down and backwards.
If I draw like this, you know?
Well, let me just read it here. Well, I should put in the units, of course. What else do I need? Yeah.
You have it.
Yeah, I think this should be it. Let's check the marking scheme. That's 7 marks.
But you will take the example.
Yeah, but I have to follow the marking scheme. Version 3, 13, 14. Let's see what we get. Right, what number was this? Alright, look. So, resistivity is equal to the resistance of a sample of unit length and unit cross-section area, or a suitable alternative definition, which basically this definition is putting the formula into words. That's fine. Did we get this for, yeah, we got this value here, and we got this graph, but you notice a couple of the points are off. We can't see this on my graph because it's so small, but that's okay. We got this as well, although mine was off a little bit because of my graph. I think I got 4.99. Or did I get 4. Oh no, that's too much.
It should be on that.
Maybe I misread my slope.
No, it's 160.
It was 0.63? Then maybe I mistyped something, or maybe they made a mistake. 0.63. Maybe, no, 0.63. I used 2 decimal places, 3 decimal places. They used, maybe they made a mistake. I remember something was wrong with one of these exams. Anyways, description of the experiment to measure I and V. Okay. And then this is the graph. They said measure in milliamps, although you notice that they made a mistake. Can you see the mistake on their graph?
Voltage.
No. The mistake is here they measure milliamps, and then here they wrote amps. Well, that's a mistake. I would take a mark away for that mistake.
I will take a mark for they didn't take any color.
Yeah. Yeah, so it is the way we thought it was.
If marking scheme is having the mistake, then we will be awarded marks for that.
Yeah, don't worry, I'll put it into my report. Now,
I hope they make a lot of it.
we might have to look at this a little bit, but I don't recall this being in the syllabus.
This is for the experiment.
Yeah. Yes, forget about it then, I suppose. Okay.
Now this is.
So I think this was. I thought this was good question.
Just the same thing as you know that.
Waves. That was a hard one. That's the atoms one. Maybe we'll do a section A question. Wait. Did we finish that fields question the last day? Did we? No, we didn't. The planet.
You can take, I don't know.
No, I think we stopped after we got, remember, we worked out like 1 year. This was only part A. We'll finish by doing the rest of the fields question. Can you open up the exemplar exam, please? I don't have it saved. You have it open? Hey Donald, who are you looking for? Are you lost?
No, I'm looking for a marker.
You will not find one in this room, I'm afraid. You could check across the way.
Yes, you're all
We're all digital here.
I heard that you should throw on the lottery.
Who'd you hear that from? Don't. He comes out with great stories now.
I just bought the lottery yesterday. I heard that and said, no, I have to buy one. Did you ever buy a lottery?
Yeah, sometimes. But
Did you ever won?
the most I ever won was maybe like €8. I won. The most I ever won, I think, was on a football game. It was €20. Bet. And then the last bet I made was for, do you know the Grand National horse race? I won €8 on that about.
I play straight cards, they are good, like.
They're boring.
No.
Oh, they're okay.
Like, from €1 that you can.
Okay. Right, exemplar. Were you talking to Iyad or Adnan? Right. Yes, Musharif. Musharif! We only did part A. So part B. What is gravitational field strength? So you can use the formula. I think it's Gm over R squared, which for Earth is 9.81 newtons per kilogram, which means the force due to the gravitational pull of the Earth per kilogram. So every kilogram has a pull of 9.81 newtons. What's wrong? You don't seem happy.
Can I say the force that a free falling object will feel?
A 1 kilogram free falling object. Yes. Mayor, come on. Part 2. use the fact that the radius is this, calculate the mass of the Earth. Well, that's easy because you know this is 9.81. You know the G is 6.67 times 10 to the minus 11. We want the M, and the OR is...
It should be square, yeah? R square.
Yeah. Okay, so then you get M is 9.81 times 6.37 times 10 to the 6th squared over 6.67 times 10 to the minus 11. Can you hit that? No, none of these have calculators out. Please, yeah. Should be a big number. Wait, I'll tell you what, Sharif, you type this in, Mir.
Yeah.
Go to Google and type in mass of the Earth, and let's see if we get the same answer. And we'll see what Sharif gets. Yeah?
10 to 14, 24.
Yeah. 5.972.
Close enough. Good. Right. What is the density of the Earth? Okay, how can we get density? Mass over volume, which is mass over 4 over 3 pi r cubed, which is your answer you had a moment ago, and then 4 over 3 pi r cubed, and the r is 6.37 times 10 to the 6th. Actually, I've got my calculator here, so fraction. Now, again, Mir, could you look it up on Google, and let's see how close we are. The density of the Earth. That's grams per centimeter cubed. So yeah, that's 5,505. Yeah, it's about 5,505 kilograms per meter cubed, or as you have it, 5.51 grams per centimeter cubed. Good. Okay, so far. The last part is, yeah, we'll finish on this. This will be nice. In a simple model of hydrogen atom, the electron is in the ground state at 5.3 times 10 to the minus 11. So you have your proton, you have your electron, and the distance here in the ground state. Do you know what the ground state is?
The vacuum?
No?
It didn't say proton.
Well, hydrogen.
Around it. No.
I suppose it could be hydrogen too, yeah, but doesn't matter. Well, when we say simple model for hydrogen, the simple model of hydrogen is one proton and one electron. That's what they mean by simple. 5.3 times 10 to the minus 11. Does anyone remember what the ground state is?
I think like it's not moving.
No, it's definitely moving. It's in orbit.
So let me check.
The ground state is the lowest energy state. E1.
Low spin state.
Yeah. Okay, well the first one is fine. It's what is the force?
F equals M1, M2.
No.
That is constant.
That's a constant.
Yeah.
Q1, Q2 over R squared. And the K is in the formula book. It is
1.3.
there. 8.99 times 10 to the 9. This is Coulomb's law constant. Don't mix that up with the constant in the PV equals nRT or kRT. So it's 8.99 times 10 to the 9. 8
If
point,
you have it here, also,
no, well, maybe.
1.5.
Okay, well, I typed it in anyway, so it doesn't matter. What is the constant number for the electron?
Charge, yeah?
Yeah,
23.
that's what I thought. So 23, which is the same.
As the
So it's just squared here, and the distance squared. What was the distance? 5.3 times 10 to the power of minus 11. We get this much. Let's put that in micronewtons. 82.2 micronewtons. How many marks for that? 2 marks. And lastly,
the kinetic energy, you just move the r squared by r.
that's potential.
Ouch.
I know. I
Then you
know.
have to get the...
Yes.
But the potential for the kinetic energy.
Yeah, but the electron's not moving, so it's not like we can say here is here. It's just at one time. You know? No? We can't do it this way. We need to have 2 points in time. We only have 1 point in time. The ground state. We don't have other states. It's not like the electron went from here to here.
So how can you...
But that's what I'm about to do. Okay, so, come here. Please, if you're going to come to class, listen.
Yes.
So we want the kinetic energy. Okay, so the kinetic energy is a half mv squared. Do we know the m? Yes, because we can check it on our calculator. It's the mass of an electron. Easy peasy. Do we know the v squared? No. But this force is a circular force, true? And we also know that for circular motion, F is equal to mv squared over r. So what does mv squared equal? F multiplied by r. So I can rewrite this kinetic energy formula as a half F r. Because we know the half, we know the force, and we know the r.
Where does the m go?
Because mv squared is equal to fr. Oh, sorry, so mv squared I replace with fr. So, this number I still have it on my calculator.
It's the same, no, it's not the same.
Multiply by a half, multiply by the radius. And the radius is 5.3 times 10 to the minus 11. That is a small kinetic energy. I think I'll put it into electron volts. Yeah, 13.6 electron volts.
Then we have to...
Yes, if they don't care about the unit, they don't care about the unit, so you can use whatever unit you like. Let's check the answer before you go. I know you're dying to go. This is right here. I'm just curious to how they did it, because I feel like my way of doing it was a very quick and easy way. Do you know what I mean? Loading. They did not convert into electron volts. And they used kind of the same idea, except they worked out what the V was.
Yeah, it's the same way.
It's the same way, but just much harder. This is what I got previously, was it? Yeah, 82, yeah. And we checked these on Google, so we know that these are right. The force acting on a unit mass. So, earlier you asked me, could you say the free-falling one? It's important that you mention either unit mass or 1 kilogram of mass. Okay. So in our next physics class, we've just completed the exemplar. Do you want to continue going through exams, or do you want to concentrate on particular topics? Continue through exams. Now, do you want to continue going backwards in time like how I am doing it, or do you feel brave enough to go all the way back to the first year and go forwards in time? Because those first year exams are the hardest ones. No.
The way to do it seems to be
Yeah, now remember, is 2008, 2009 missing? No. They changed it. So this person who's writing your exam, I believe, wrote these 3 years. So if you can do every question in these 3 years, then you're okay. Mere.
If I did from
What did I just say?
If I did from 15 to 10.
Oh, sorry. I'm so sorry. I'm so sorry. I have it upside down. Samir's distracted me. From here to here, this person who wrote these will write your exam. So if you can do all of these, you'll be fine. Now there's a lot here, but each year there's different versions. But as you see, the versions are sometimes not very different. So what you could do is do version 1 in each year.
And then if you have
Then version 2.
of all the years, yeah. Okay.
It doesn't really matter. The most important thing is that you're practicing questions. That's the most important thing. Yeah. Okay. Well, how about next time? How about we start at this year?
Why?
Because we've kind of been looking. Alright, whatever. We'll talk about it next time. We'll talk about it next time.